Let's just jump right in with a pretty stark warning. When artificial intelligence messes up in most industries, it's usually, well, just an inconvenience. But in healthcare, AI errors can cause actual physical harm to patients. It's literally a matter of life and death. The truth is, healthcare AI is completely at the mercy of the messy, imperfect data we feed it. If we feed it holes, it doesn't just quietly fail. No, it hallucinates. It confidently spits out plausible-sounding but dangerously incorrect medical advice.
So, in this explainer, we're going to uncover these invisible threats lurking inside medical records. We'll quickly explore the massive problems of unstructured and missing data and how the everyday habits of human doctors are actually our ultimate frontline defense.
We tend to imagine hospital servers filled with perfectly neat spreadsheets, right? Well, the reality is actually pretty staggering. A massive 70% of healthcare data is completely chaotic and unstructured. Only about 30% is that neat, organized data that computers absolutely love. So that means the vast majority of a patient's medical history is just floating around in formats that AI algorithms fundamentally struggle to understand.
To put that into perspective, on one side, you've got structured data. This is your patient demographics, basic lab tests, billing codes. It lives in neat little rows and columns. AI eats this stuff up instantly. But then, on the other side, is the unstructured data. The chaotic stuff. We're talking 3-page typed doctor's notes, PDF discharge summaries, radiology images, even audio files. It is inherently tough for an algorithm to process, mostly because it just doesn't fit into a tidy little box.
Now you might be thinking, well, if 70% is that messy, why don't we just toss out the unstructured stuff and train the AI only on the neat 30%? Man, if only it were that simple. We can't. Without that messy data, the numbers completely lose their meaning. See, AI in healthcare is essentially trying to reverse engineer a doctor's thought process. A doctor weighs a dozen complex factors to make a diagnosis, and they write that nuanced story down in their free text notes. If we ignore those notes, the AI learns absolutely nothing about the real clinical context. It just sees naked numbers without the vital story behind them.
But unstructured data isn't our only headache here. That brings us to another massive threat, which is missing data. This is information that absolutely should exist in the system for an AI to work correctly, but it's just gone. Why does it happen? Well, picture a high-stress, visceral clinical scenario. Imagine a crashing patient in the ICU. Obviously, the immediate survival of that human being takes absolute priority over a doctor logging vitals into a computer screen. Verbal orders get shouted, they get executed, but they never get digitally recorded. The data simply falls through the cracks. This missing information generally falls into 3 distinct types, and they escalate in how much of a threat they pose. First up, we have missing completely at random, or MCAR. Think of a blood sample getting lost in transit. It's a random accident, and honestly, a pretty low threat to the AI. Next is missing at random, or MAR. Now this one has a pattern we can actually track, kind of like elderly patients missing appointments because of mobility issues. Because we know the pattern, we can account for it. But the third type? Missing not at random, or MNAR. This is absolutely the most dangerous threat to medical AI.
So what makes this third type so dangerous? The crucial point here is that missing not at random is tied directly to the severity of the disease itself. Let me break that down. The sickest patients often have the most missing data because, frankly, they are just too ill to show up for follow-up appointments. Or maybe patients with a really poor prognosis aren't advised to get expensive, painful tests. Their data is missing precisely because they are severe cases. The AI doesn't know why the data is blank, it just sees a void, and this creates an extreme, deeply hidden bias.
And the result of that bias is honestly terrifying. Because those severe cases essentially disappear from the digital records, the AI algorithm gets completely tricked. It looks at the database and ends up training itself almost exclusively on the healthier patients, the ones well enough to actually show up and get tested. If you were to deploy that AI into a real ICU, it would spit out dangerously biased predictions. It would severely underestimate mortality rates and misjudge high-risk patients because it has literally never been trained to recognize what a truly sick patient looks like.
Now, you'll hear tech companies claim they can just magically fix these holes using advanced machine learning to guess the missing numbers. But we absolutely cannot just rely on statistical fixing. Trying to fill complex clinical holes with algorithmic guesswork leads straight to AI hallucinations and data overfitting. It's that classic rule, garbage in equals garbage out, right? Instead, what we really need is a total shift toward proactive data governance. We need high-quality data captured accurately at the bedside by humans long before the AI ever even touches it.
So,
Let's pivot over to the actionable part, the frontline defense, focusing on clinician-led strategies. Because if fancy algorithms can't save us, our human safety nets definitely can.
There are 4 essential steps every clinician needs to adopt to make this work. Starting with step 1, structure over story. We all know free text is essentially where clinical data goes to die. So doctors need to choose drop-down menus, checkboxes, and radio buttons in their software instead of writing out a massive 3-page narrative. By structuring the data at the exact moment of entry, the AI can actually read and use it instantly. Moving to step 2, we have the rule of 3. Now, we know doctors suffer from terrible documentation fatigue. You just can't ask them to fill out 100 mandatory fields per patient. It's impossible. To combat this, hospital administrators and clinicians have to agree to prioritize just the top 3 non-negotiable variables needed for a specific AI algorithm. It's basically the 80-20 rule in action. Securing just that crucial 20% of prioritized data will drive 80% of the AI's intelligence. It keeps the data accurate, and more importantly, it keeps the doctors sane. Step 3 highlights a massive pitfall in medical charting, the danger of silent normals. Listen, you can never, ever leave a field blank just because a patient's test result was normal or negative. If a doctor skips a field thinking, oh, that's normal, no need to type it out, the AI doesn't read it as normal. It reads it as missing data. Clinicians must explicitly document those negative results to stop the AI from seeing a fatal void and making a wildly dangerous assumption. And finally, step 4. To lock this whole thing in, clinicians have to follow the golden rule, which is finalizing their documentation within 60 minutes of the patient encounter ending. Why 60 minutes? Well, because after that first hour, the decay of human memory aggressively sets in. The really rich, nuanced context of why a specific test was skipped or why a certain medication was chosen, all of that gets lost forever if it isn't documented in real time. Basically, document as you go, before the memory fades. All of this leaves us with an incredibly powerful thought to ponder as we wrap up this explainer. We spend billions of dollars developing the most advanced artificial intelligence the world has ever seen. But as this tech rapidly moves into our hospitals, it isn't the code that's going to decide our fate. It is literally the simple, everyday documentation habits of human doctors, clicking a checkbox, explicitly noting a normal result, charting within 60 minutes, that will ultimately decide if AI saves patient lives or creates dangerous, fatal illusions.